Alright, so today's goal, dealing with relations and functions. What is a function? It means every input has exactly one output. That means x values only give you one y answer. So an example of a function. See how you have 3, 4, 5, 6? And you don't have an x value repeating ever? That means it is a function. See here how you have right there, you can stop right there. You don't even need to have all these. This could still be 5, 6, 6, 7. See how 3 gives you 4 and 5? That means it's not a function. So we want to determine whether each relation is a function. Okay, so we have 3, we have 5, we have 10, we have 3. See how the 3 repeated? So this is not a function because 3 equals 4 and 6. Okay, so let's look at another example. So we have 3, we have 4, we have 5, we have 8, we have 6, we have 7. Did x ever repeat? No. So yes, because every input has exactly one output. Okay, so let's take a look at more of dealing with relations and functions. So this one is a relation, this one is a function. Alright, so it says determine if the given relation is a function. Explain your reasoning. So see how it has y squared equals x? We need to get it to solve for y. So if we square root this, we get y equals plus or minus the square root of x. Because remember, anytime you take a square root, you get that. So if we think about that, if we said x was 3, doesn't that mean that x was 9? Doesn't that mean that y is plus or minus 3? So no, not a function. Now y equals x squared. This one is a function because I don't like this right now, so I'm just going to say x and y. So if I plug in negative 3, I get 9. If I plug in 0, I get 0. If I plug in 3, I get 9. It doesn't matter that the y values are repeating, but the x values are not. So if we back up, if you look, here if I go x and I said 9, it's plus or minus 3. See how it gives you two answers, or another way to think about that would be 9, 3, negative 3. So see how that repeats itself? Okay? So absolute value of x. So if I said, what's the absolute value of negative 1? It's 1. What's the absolute value of 0? 0. What's the absolute value of 1? 1. But the y values can repeat, but do the x values ever repeat? No. So yes, it is a function because every input has exactly one output. Okay, let's take a look at some more. Alright, so it says find the range of x plus 5 over x minus 10. So you want to think all real numbers. But if we look in here, and we remember, see how this is a horizontal asymptote? So really, and there's multiple ways to look at this. We can look at the graph and see how it's never crossing 1. Or see how these are the lead coefficient divided by the lead coefficient. They're the same. And what's 1 divided by 1? 1. So y equals 1 is the horizontal asymptote. So that means the range is all real numbers except y does not equal 1. Okay, we'll talk about that more in class if we need to. Alright, here it says find f of x equals 3x plus 5 for x equals 3. That means just plug it in. So f of 3 equals 3 times 3 plus 5, which is 15, or no, not 15. 3 times 3 is 9. 9 plus 5 is 14. So it says, here it says, for the function defined by f of x equals 13x plus 17, find f of 2. So that means f of 2 equals 13 times 2 plus 17, which is 26 plus 17, which is 43. So see how what they're saying to plug them in, because this is like f of x, but see how they replace the x with the 2? Okay, let's take a look at some more. So it says solve g of x equals 2 times the absolute value of x plus 1 minus 2 for the following situations. G of 3 plus g of negative 5. So what that means is calculate g of 3. Well, 2 times the absolute value of 4 is 8, minus 2 is 6. And then calculate g of negative 5. Which is actually 2 times 5, because the absolute value of negative 5 is positive 5. So you get 10 minus 2 is 8. Now go back. We're adding them. So what's 6 plus 8? 14. So final answer, 14. Okay? So here we'd have g of 2 equals 2 times the absolute value of 2 plus 1 minus 2. 2 times the absolute value of 3 minus 2. 6 minus 2, 4. G of negative 1. 2 times the absolute value, negative 1 plus 1 minus 2. Equals 2 times the absolute value of 0 minus 2. Well, 2 times 0 is 0. 0 minus 2, negative 2. So now we have 4 minus negative 2. Add them together, you get 6. So hopefully you're remembering this stuff, so let's keep going. Alright, it says solve f of x equals 3x divided by the quantity x minus 5 for the following situations, when f of x plus 4. So just like we were substituting in numbers, now we're going to take x plus 4, and anywhere you see an x, plug it in. So we get f of x plus 4 equals 3 times the quantity x plus 4 over the quantity x plus 4 minus 5. Distribute it out, you get 3x plus 12 over, well, 4 minus the 5. So x minus 1. Okay? So for x minus 5, we're going to get 3 times the quantity x minus 5 over x minus 5 minus 5. So you get 3x minus 15 over x minus 10. Because you distribute, and negative 5 minus 5, negative 10. Okay, so hopefully you're remembering these. Let's take a look at some more. Alright, piecewise function. A function where you have different equations to use depending upon the value. So see how this function is in different pieces based on these values. Okay? So when I look and I see evaluate for x equals 2. Is 2 less than 0? No. Is 2 between 1 and 5? Yes. So I got to use the x plus 15. So f of 2 equals 2 plus 15, 17. So there's 1. Now for the next one, it's negative 3. Well, that's the one that's less than 0. So you go f of negative 3 equals negative 3 plus 3, which is 0. So there's answer 2. One more. X equals 6. Is that less than 0? No. Between 1 and 5? No. Greater than 5? Yes. So we're using x minus 25. So you get f of 6 equals 6 minus 25, which is negative 19. So there are all three of our answers. There's some other thing in the notes I didn't go over. If you have questions on reading through, ask me in class. We'll see you guys in class.